Guys, Koda Arcanis here. Welcome back to the workbench. So today, if we're going to be coding up the icing controller that we built in the last episode. So, quick recap. We have tub of water, pump, water goes out, water comes back in. We have flow meter, which is connected to D2 on the nano. The temperature out. So it's temperature out of the system. That's connected to D10. The temperature in, that's connected to D8. And because this is an icing system, we actually have a bypass solenoid here. The bypass solenoid is connected to D12. So that's your output, and these other three are inputs. So without further ado, let's get up the workbench, Arduino, and let's start coding. Right, so hopefully you've seen, or you'll go and watch some of the other videos, because I'm not going to explain how we set up, how we monitor temperature and stuff like that. I've got other tutorials out there, and if you watch the controller for the cooling system, I'm basically going to be doing exactly the same code. So first off, let's load in the library for the temperature. So this is the temperature system, one wire temperature one, written by Texas Instruments. Let's set up temperature in and out, exactly the same as the other controller. Let's set up the loop, and let's just check to make sure this works first. So serial dot println hi. So let's just check to see that we've got connectivity and these don't throw any errors. So let's upload that. It's uploading. Thank you. Let's put the serial monitor on. Serial monitor. Hi. Excellent. And if we clear that, you'll see it keeps going back in. Let's turn scrolling on. There you go, scrolling around. Sweet. So, if you remember, we need to first copy those lines in. So I'm just copying and pasting pretty much from the previous video on how to set up the controller. So, selecting temperature in, temperature out, set the resolution to 9-bit because we want fast. We don't want to take time to do the calculations, and I think it takes up to half a second if you put that up to 12-bit. A couple of methods here, one to pull the temperature from the input, one to pull the temperature from the output, which is just calling these, which is then just set up here. So temperature in at pin 8, temperature out at pin 10. And then what we'll do is just to test it, we'll go serial out, calculate input temp, calculate output temp, and then we'll just do a delay 2 seconds. So this will just go through, calculate 2 temperatures, and then let's just put a line here so we can see when it's gone around the loop. There we go. So let's run that. It's running, uploading, done. Let's clear it. So these hopefully, see, there you go, input, output, input, output. And it's, yeah, there you go, 21 degrees, 22 degrees in the water at the moment. So the output temperature is actually floating. So it's in the output stream of water. It's actually not touching the water. So the actual water in the tank at the moment is 21 degrees. Phenomenally warm. Right, so we're now picking up and reading the temperature, and they're about the values I'd expect because I stuck my finger in the water before and it's about that warm. So what do we do now? Well, we have a flow rate. So let's get, if you remember, or if you're interested, we have to need an interrupt. So here we have a counter which will keep count of how many pulses per second we're getting. actually, how many pulses we've counted in the last period of the flow sensor, because it pulses. So this is the variable to keep track of what the last time. So this keeps track of the last time that we started. So what we now need to do is set up the interrupt. So we attach the interrupt to pin interrupt 0, which, if you have a look at the diagram, which I can't find, hang on a second, I've put it down somewhere else. Where is it? Where is it? Here it is. So you look at the Arduino pinout. Hang on a second. So if you look at the pinout document here, you'll see that int 0 is connected to D2. So you want to, we're connecting the pulses that are coming in from the flow meter into PD2. So that's cool. So that's the interrupt. So every time we get a pulse, this will get called. Every time we get a falling edge, so when it goes from 5 volts down to 0, it'll increment the counter. And then we have this method, which again, put there. So calculate the flow. So we save the count, set it to 0. So we now know that's the time we're working with current count. Get now, calculate how long we've waited, and then reset last to now. So basically what we're keeping track is what's the delta between the last time we checked it and now, and that's how many pulses we've counted. And then you run through this math. Now that 34, we're going to have to check by measuring how much water's flowing in the system when I turn it on. But hopefully that should be vaguely right, because I've got exactly the same sensor on the output, and the icing and the cooling system has the same model of sensor bought at roughly the same time, so they should be roughly calibrated. And then so what we'll do is we'll get this in here, and we'll say calculate flow. So we should get 22, well, 21 and a half, 22, and 0, because I haven't turned the pump on yet. And how are we going? Hopefully that should all work. There you go, 0. So if we clear that, I'm now going to turn the pump on. So apologize if you hear a slight hum in the background. The pumps aren't exactly silent. Right, it's that one there. Yep, so that should be blowing. I can see the water flowing through the system now. It hasn't. There we go. It started to dribble out. So how are we going? Okay, we're not getting any interrupts. Interesting. Why is that flow sensor not working? Right, so bit of debugging, bit of problem shooting. Yeah, I've got a dodgy flow sensor actually on the actual cooling system, so I'm going to have to rip that out, buy a new one, put a new one in. But we'll just carry on. We'll pretend that's working. We'll pretend it's giving us the right values. I've checked the flow rate, and yeah, we're running at about 18 seconds rather than 20 for the system. So it is actually pumping slightly faster through here, but we'll calibrate this later. But the key thing is here, we have the temperatures, we have a flow rate of 0. Yeah, I think the sensor's got broken or something. So water's flowing through it. The system's kind of working. Let's actually just go to tap, see if that fixes anything. No. Okay. So that sensor is dead. So I shall have to rip it out, put a new one in, which is annoying because it involves a whole bunch of gluing, but hey, never mind. So let's just carry on. So let's pretend we're calculating the flow correctly and everything's hunky-dory. What we now need to do is set up the pin for the relay, because we actually have slightly different. So we don't actually need to do this because I think it's picking it up, but so what we're saying, pin 12, we want to output, and then what we'll do is every time around the loop at the moment, we'll just do, we'll just switch that to a delay, to delay of 1000s, and then we'll say digital, oh, right, pin 12, value to high, so that should turn the relay on. Wait a second, and then turn it off. So if I apply this, I should sit here. I should hear a click, 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 click going. Yep, I can see the light turning on and off. So that's quite happy turning on and off once a second, which is exactly what we want it to do. So that's on. So what we'll do is just go put on up here, void turn by pass on, and void turn by pass off. And then what we'll do is we'll just go, so that turns it on, and that turns it off. So now we've got these two little methods we can call. So what I'm now going to do is copy and paste in the serial code. So we'll come back up at the top. And if you remember, that's how much the buffer is. This is where we're currently working on the buffer. And these just are flags to say whether or not we've actually picked up any characters so far. So we come down here, just copy and pasting from the previous chunk. Because realistically, this is almost identical to the previous one. So what we've got here is the update buffer method. If you want to see me debugging this and putting it in, go have a look at the tutorial on serial communications. And then we process the command ID. Well, actually, we're not. We're now the ICE system. And if we're reading, we want the input temperature, the output temperature, and the flow. So that's absolutely fine. What we want to say here is the end bit is this. So the loop, you get rid of all this stuff and just say update a buffer. If we've got a command, process it, reset the buffer, wait for the next command. And the commands we've got are ID, reading, and then we need to worry about, what are we going to do to turn it on and off. So I'm just looking at the code for the, there we go. So it's enable and disable. So if we get the command, so it's ICE enable. Funny enough, that is, we're just going to call turn relay on. And then if we get the command ICE disable, we're going to turn the relay off. So let's push that up. What have I done wrong? Oh, turn bypass on. Oh, one day I will learn how to spell on, off. Push this up again. Okay, so we clear this. No input now. No output, sorry. So let's say ID. Where the ICE. Brilliant. Reading, please. Okay. And can we please turn ICE enable? So I should hit C click, and you have to take my word for it if it turns on. It does. And then we do ICE disable. And it turns off. Sweet. So that's working. That's now ready to go. we have a working ice system now, so we can. So yeah, that's another part done. So if you look at the overview, I've got a cooling system, an ice system, and then a controller system, which disables the fans, the um, lights, the laser. So it actually enables the laser, but it interrupts the laser. So if it thinks that the operating conditions are wrong, it won't let you turn the laser on. So it's just an extra bit of safety I'm building in. So hopefully you enjoyed that. Please have a look at the controller tutorial if you want to see. Actually, not a tutorial, the controller part where I do the coding. If you want to see a bit more of an explanation, and then go back and look at my various tutorials on each individual bit. So you'll see how I've got the temperature reading working, how I've got serial comms working, how I've got the relay working. There's much more detail, including circuit diagrams and stuff like that, available. So yeah, hopefully you've learned something. Hopefully you're enjoying watching the project build up, because I'm definitely enjoying getting this done. It's been on my to-do list for too long. So like and subscribe, and I'll catch you guys later. Bye.